Rutherford came with the alpha particles from which he discovered the nucleus and uh, the electrons, and that nucleus is in the center. Electrons are in a much larger volume. However, at that later he also postulated for each electron which has a negative charge, there should be a proton. That should be the nucleus. So initially it was thought nucleus has only proton, and there was some problem with that. For each positive charge, there is only mass 1. But some atoms like helium, okay, helium has only 2 electrons, so it can have only 2 protons. But the mass of the helium must almost double than that of the 2 protons. That was a confusion. So Rutherford came with an idea. Maybe some of the electrons are not outside. Some of the electrons are attached to proton and sitting there. Means helium has 4 protons. 2 of them are already neutralized with electrons. The other 2 are positive charges. That was not supposed to be the case, because to have this 10,000 times bigger electron clustered into a tiny nucleus is energetically almost impossible. Heisenberg calculated that in Germany, okay, and even his own students, Rutherford students, was doubting that, okay, and it was subsequently proved it is impossible to put a big bird back into this original egg. That is what is happening. The whole electron coming back to the nucleus, energetically not possible, okay. Then he had a student, and Rutherford is the one who nurtured him. Rutherford was so fortunate to have such a wonderful family of students, okay, and this student, he was from UK. His name is James Chadwick, okay. James Chadwick even spent 4 years in prison in Germany, okay, and he had this in the back of his mind. And he even worked with Mary Joliot-Curie, Irene Joliot-Curie, Marie Curie's daughter, who was also a Nobel laureate with her husband, okay. And then I know some observations were made that if alpha particle, Rutherford's famous alpha particles, are hit on some of the small elements like lithium, beryllium, or boron, okay, some particles are coming out. And that is not positive, that is not negative, that has a lot of energy. So they thought that is gamma rays. Gamma rays are electromagnetic radiations, okay, and they have momentum. That is h divided by lambda, okay. But that momentum is not enough to push something else, which are massive enough, okay. But what happened? These radiations coming from the lithium, beryllium, or boron, when hit by alpha particles, can push protons out of paraffin wax, our candle wax, okay. That has a lot of hydrogens, and protons are pretty massive, okay. And it is like a little baby throwing a mustard seed at or some coconuts, and one coconut is flying away with the same speed as that of the mustard seed. Sort of impossible, okay. And then since they are positive, and this has it was found this has a whole lot of mass, okay. And really, with when working with Frederick and Irene Joliot-Curie, he found out this is a totally new particle with a mass 0.01% more than that of proton, okay. And that was the discovery of neutron. Neutron was discovered. Neutron, like a proton, is not a fundamental particle anymore. It is made of 2 down quarks and 1 up quark, okay. Neutron has another major capability. Neutron can, since it is not charged, neutral, nobody will suspect him. It can get into the nucleus and disrupt the nucleus. That is the principle of atom bomb, okay. Even in hydrogen bomb, when deuterium, that is a hydrogen with 1 proton and 1 neutron, is fused with a tritium, that is 2 neutron and a proton, okay. 1 neutron is coming out. That neutron can combine with lithium to make it helium. Okay, helium is sort of innocuous, but energy requirement is extremely high, millions of degrees Celsius. Okay, but those things can happen. So we have a brand new particle, really a combination of particles. Okay, that is neutron. That is the discovery of neutron. Makes some sense. Now we have electron, neutron, and proton. Bye.